Hey guys, this is a notes for 2.4 called Valid Arguments. Here's a little paragraph on the top, a little real life scenario. You don't need to copy this down, but it'd be good to really read it over and listen to me as I read it to you. It says, during a crime investigation, a detective gathered a group of suspects in connection with the crime. The detective knows that all thieves are guilty. That's one true statement that they know for sure. However, none of the suspects are thieves. So there's another true sentence or true top statement that they know. So two statements: all thieves are guilty. None of these suspects are thieves. Defense lawyers argue that these two statements imply that none of the suspects are guilty. Are the lawyers correct? Basically, what the defense lawyers are making is they're making what we call an argument. They're using true statements to come up with a conclusion. So just a couple of key words here for you. An argument is a group of statements consisting of two or more premises and a conclusion. A premise is the next key word, since it's right here, premise. We want to know what a premise is, and it's a statement that is given or proven to be true. So a premise right here is a statement given or proven to be true. So we know it's a true statement. That's the key right there. We know it's got to be true. A premise is true. So the premise that they're giving here is that all thieves are guilty. That's a true statement. And they're giving you a premise that none of these suspects are thieves. So they're arguing that because of those two statements that none of these suspects are guilty. Let's draw a Venn diagram to illustrate this. So first we'll take a box. Let's make a box like this, rectangle, and we will represent, this box will represent all people. Now in this Venn diagram we need some circles. So let's get a circle here. And so we'll have a circle here. This circle here will represent people who are guilty. These are people that are guilty people. Now it does say in this paragraph here that all thieves are guilty. So inside of the guilty, we need another circle for thieves. All thieves are guilty, so all of the circle will fit inside of the guilty circle because all of the thieves are guilty. Now it says that none of the suspects are thieves. So we need a circle for suspects. We need a circle for suspects, and actually let's highlight this circle and make it, let's see, can't make it clear, can we? Alright, so let's do this. Let's get rid of this circle. Let's make it have no fill. So it'll look like this. So it will overlap with the guilty people. These are our suspects. So now we just have some of the suspects could be guilty, but none of the suspects are thieves. So we could have some guilty suspects. So their argument is not true. You could have some suspects that are guilty. A counterexample to that is that some of these suspects might be liars and maybe they really are thieves and they could really be guilty. So this is not a valid argument for them to have. Now to have a valid argument, which is what our topic's about, there are some laws that we have to follow. So let's look at the next page here. 3 laws of deductive reasoning that will make a valid argument. First one is the law of detachment. They have weird names. I'm just going to tell you that right now. They got weird names, but they're pretty easy to understand. Law of detachment is the easiest one of the 3. If P to Q is true, and P comes true, then Q will come true. That's basically, in a nutshell, what the law of detachment is. Here's an example. If you miss practice, you will not play in the game. Say you're on a football team, and you miss practice, then you're not going to play in the game. That's the coach's rules. That is a conditional statement, and it's a true statement because he's made up the rules. Tuesday comes along and you miss practice. You get sick or you get a family emergency or something, so you can conclude that you will not play in the game. That's law of detachment. If this comes true, if you do miss practice, then this has to come true. You will not play in the game. So that's called law of detachment. This is a valid argument based on the law of detachment, that you will not play in the game. So that's the first one, law of detachment. The second one is law of syllogism. And again, you can pause the video anytime and just write it down if you need to. Again, I told you they got weird names. Law of syllogism. A syllogism is a common deductive argument. We're going to use its common a lot in using facts. Syllogism says if P to Q and Q to R are true conditional statements. Basically, you've got a P statement, you've got a Q statement, and you've got an R statement. So if you put if P then Q, and you put if Q then R, and they're both true statements, then if P then R has to also be true. So let me show you how that looks down here. Let me do something really quick to cover this up, because it'll make more sense. Not for this circle. I don't want a circle. A rectangle. Okay. Okay, so it'll make more sense here. Now, what conclusion can you make from the following statements? Okay, so the first statement is a P to Q statement. If a bird is the fastest bird on land, that's your P statement, fastest bird on land, then it is the largest of all birds. That's your Q statement. If it's the fastest, then it's the largest. That's P to Q. Your second statement, if a bird is the largest of all birds, which was our Q statement up here, so again it's Q, just another Q. If it's the largest of all birds, that's our Q statement, then it's an ostrich. Ostrich represents our R statement. So if it's the fastest on land, then it must be the largest bird. If it's the largest bird, then it must be an ostrich. So using the reasoning from law of syllogism, we can put the last two together, and we can say if a bird is the fastest on land, then it is an ostrich. We can go straight from P all the way to R. We don't need to use Q in the middle. If we know that these are both true statements, we can go straight from P to R. We can go straight there. So that would be the law of syllogism. Again, weird names, but they make sense. Because if this happens and these two are true, then this has to be true down here. The last one is called the denying the consequent, or denying the conclusion. It's actually also pretty easy to understand. If the conclusion is denied, then the hypothesis can be denied. So, or basically, the hypothesis is also denied. Here's an example. If a suspect is guilty, then he must own a gun. Okay, there's your statement that's true. If a suspect is guilty, then he must own a gun. And then you look at the next statement, it says the suspect does not own a gun. Well, we just denied this conclusion right here. We just basically said this conclusion does not work. When you deny the conclusion, then you can basically say the suspect's not guilty. Because if he's guilty, he had to have owned a gun. If he didn't own a gun, then he can't be guilty. So if you deny what the conclusion says, then you can deny what the hypothesis says as well. So that's called denying the consequent. Again, weird names. Sorry, it's just the way they do it. The conclusion was denied in the second statement. The second statement right here denies our conclusion. Therefore, we can deny the hypothesis and basically say that can't be true. They're not guilty. Here's a couple of examples. Can you identify the rule that makes the valid argument or the argument valid? Pause the video on each one and see if you can figure it out. And then see if you're right. I'll put them in. I'd like you to actually try them on your own. Pause each video and see if you can get it right. If the milk was left out of the refrigerator, then it is sour. The milk was left out of the refrigerator. The milk is sour. Pause it, see if you can figure out which one that is. Okay, we're back. That is the law of detachment. Law of detachment says if P to Q is true, if you leave the milk out of the fridge then it's going to be sour is true, and you actually do the P right here, then Q is going to come true. The milk will be sour. That's law of detachment. If you tell a funny joke, then your friends will laugh. Your friends do not laugh. You did not tell a funny joke. Pause it, see if you can figure out which one it is. That's the one on this page, denying the consequent. That's the one where you're denying the conclusion. You're saying that their friends did not laugh. The conclusion is denied, so your hypothesis has to be denied. And the last one, if you're the fastest runner, then you win the race. If you win the race, then you get a trophy. So basically we can go from the P statement all the way to the R statement. If you're the fastest runner, then you're going to get a trophy. That is the law of syllogism. Law of syllogism. That is it. I have one last slide. It is a riddle. If you can be the first one to tell me the answer of the riddle tomorrow in class, you will get a prize. Basically, it says you've got this list of animals. Which animal is 2 animals below, the animal that is 5 animals above, the animal that is 2 animals above, the animal that is 3 animals below, the mouse. Good luck, and we'll see you guys tomorrow.